Welcome everyone. In this video, we'll go through the method required to determine the enthalpy of solution for a substance experimentally. Let's get started. Here's the question. Describe how you would carry out an experiment to determine the enthalpy of solution of anhydrous magnesium chloride. You should use about 0.8 grams of anhydrous magnesium chloride. Explain how your results could be used to calculate the enthalpy of solution. It can be very daunting when you are faced with a long question like this. It might be a good idea to make some notes on a rough piece of paper before you start. Ask yourself questions such as, what are the equations associated with the experimental enthalpy changes? What do we need to measure? What do we need to control? How will the apparatus be set up? And what will the graph look like? We are told in the question that the experiment involves anhydrous magnesium chloride. Since we have to work out the enthalpy of solution, we can assume that the magnesium chloride must start off as a solid. We could use a weighing boat and a two-place digital balance to work out the amount of magnesium chloride using number of moles is equal to mass divided by molar mass. A polystyrene cup is used as a good insulator. It minimises heat loss to the surroundings. This is often placed inside a glass beaker for stability. A known volume of water is added to the polystyrene cup using something like a measuring cylinder or a volumetric pipette. The mass of the reaction mixture in grams is approximately equal to the volume of water in centimetres cubed. A thermometer is used to measure the temperature. The solid magnesium chloride is added to the water and the mass is measured by difference. It is not appropriate to measure the mass of the magnesium chloride by including the washings. Post in the comments if you can explain why. The energy change, Q, is equal to mc delta T, where m is the mass of the reaction mixture, C is the specific heat capacity of the reaction mixture, and delta T is the temperature change. The enthalpy change is given by minus Q divided by N. Enthalpy change is often given with units of kilojoules per mole. It is necessary to convert joules to kilojoules, and I've highlighted this by changing uppercase Q to lowercase q. If the reaction mixture gets hotter, Q will be positive. If the reaction mixture gets hotter, it's an exothermic reaction and a negative enthalpy change, hence delta H is minus Q over N. To get a more accurate temperature change value, a stopwatch is often used to record the temperature at regular time intervals. The temperature of the water could be measured every minute for 4 minutes before the magnesium chloride is added. At the 4th minute, the temperature is not measured and the magnesium chloride is added. The reaction mixture is stirred. The temperature is recorded at the 6th minute and the 7th and the 8th and so on. A sketch of a possible graph is shown on the left. This would be for an exothermic reaction. For the first few minutes, the temperature does not change because nothing is reacting. It takes time for all of the reactants to react, and it also takes time for the thermometer to respond to the change in temperature. When the reaction is complete, the reaction mixture begins to cool. 2 lines of best fit are drawn and the maximum possible temperature change is shown at the 4th minute. A model answer is given here in blue. Weigh accurately approximately 0.8 grams of anhydrous magnesium chloride into a weighing boat using a 2 decimal place balance. Place a polystyrene cup in a glass beaker and add 50.0 centimeters cubed of distilled water using a measuring cylinder. Record the temperature of the water every minute for 4 minutes using a thermometer. At the 4th minute, add the anhydrous magnesium chloride to the water and stir. Record the mass of the empty weighing boat. Calculate the mass of MgCl2 by difference. Record the temperature of the water every minute for a further 10 minutes. Plot a graph of temperature, y-axis, against time, x-axis. Extrapolate the graph to find the temperature change, delta T, at the 4th minute. It is a good idea to include neat diagrams in your answers. It would be appropriate to include a sketch of the expected graph in your answer to this question. You could also draw a labelled diagram of the apparatus. Finally, list the equations that you have used. The amount of magnesium chloride is calculated using mass divided by molar mass. The energy that goes into the reaction mixture is given by Q is equal to mc delta T, and the enthalpy change delta H is given by minus Q divided by N. Thanks for watching. I hope you found the video useful. Please post in the comments if you have any questions or suggestions. Take care and good luck with your studies.